I'm Russell Tytler. I'm a Professor of Science Education at Deakin University. I've been a science teacher and I've been an academic for some years now. But these days I'm mainly involved with research. We have ourselves an active science and mathematics or STEM group. We sit within READY, the Education Research Centre, that supports us with seed funding and organises support for us to work with outside institutions for research. It really keeps us, in a sense, abreast of contemporary methodologies and thinking, and so that's been a very generative part of my experience here at Deakin. There's a lot of concern internationally with engagement in the sciences generally. There's this need to develop ways of thinking about STEM education that has kids thinking flexibly and really understanding how they can be supported to do that. Really it's about engaging kids in the genuine practices of science, investigating, asking questions, exercising curiosity or developing curiosity about the world. My key research goals would have to be about improving education in STEM, and that would include changing system, curriculum, changing teacher practice through modes of professional learning, and changing the way kids think about it and engage with STEM ideas. We've been doing research around students representing and coordinating representations, and by that I mean that if you're working in science, you're not only working with words, you're working with a lot of visual representations, diagrams, for instance, videos, and also three-dimensional models. Our agenda has been to work with teachers to really develop strategies to get kids inventing representations and discussing them, analysing them, and that gives a much more powerful way of learning than simply through text.
I've been working with Russell Tytler and Peter White over the last 3 years. We've been doing lots of science and maths activities with the children. We've been focusing on the representation construction approach, which is where the children show me their scientific understandings via diagrams. The impact has been really huge in terms of the way that children learn. I've been teaching for over 30 years and this has been such a wonderful experience to see the kids being totally engaged, being able to talk about their learning and the children own it.
In terms of government policy, there's a concern with the uptake of STEM subjects through to university. So we've looked at that issue. We've looked at what's happening in other countries. We did a big study on comparison of STEM participation across 26 countries recently. So it's all around to try and get, in Australia and elsewhere, a more effective and interesting science education. More recently, there's been a lot of interest in looking at interdisciplinary ways of working with the sciences. So I've got a number of PhD students working on some very interesting and quite varied projects. I've got one, for instance, who's just started working on cosmology education. He's a very enthusiastic astronomer and is looking at bringing in data from contemporary Australian telescope into the Year 10 classroom. I've got also a PhD student who is looking at mathematics and art and science and the links between those. PhD students are great because they push you thinking, that they move you along different trajectories and they challenge you to get into new areas. We've got recognition now for really advancing a view of learning that is based around representational work. We really need to look at science as a literacy, as students learning to operate with the languages of science. And that idea underpins the Primary Connections program, which the Academy of Science has been managing for some years now. Both myself and Vaughan Prain, my colleague, were involved right from the start with that. Also, through my work with the Australian Curriculum Committee, with the International PISA Science Assessment in 2015, and with the Victorian Department on Teachers, I think there's a much better understanding of how students learn through producing and working with representations. We've had a number of large Australian Research Council projects, so the team has been very successful and it's meant we've, I think, been influential and we've been part of a lot of really good conversations internationally.